So good morning. In this case, we will be discussing about the two major topics in the finite element analysis. So the one is a weight residual method, the other is a Rayleigh method. So first of all, what is your understanding of the weight residual method? So while your problem you can solve the weight residual method means you have to carry the four basic steps as we know that is called as a point collection method, subdomain method, least square method, and guarantee method. So this is the approximate solution only we got. So when you are applying any problem, okay, we got only the approximate solution for the four types of methods. Okay. So the first of all, in this while solving the weight residual method, as we know that they given the governing equation. So after that governing equation, you have to find out the trial function. The trial function and substituting in the governing equation, you got a residual function. That residual function only we have to resolve for all the four methods. Okay, so that the residual of the particular domain problem is very important for the weight residual method. And also when you are assessing the trial function, that is also is a very important one. So when you are substituting in this, so you got an approximate solution for the each category. So let's discussing on the one by one. Yes.
So myself Nishant from third year NMCT. So let me introduce about the weight residual method. The weight residual method is an important numerical technique used to obtain approximate solutions for differential equation encountered in engineering and applied science. In many practical problems such as structural analysis, heat transfer, and fluid flow. The governing equations are complex and exact analysis solutions are either difficult or impossible to obtain. In such cases, numerical methods like weight residual method play a vital role. In this approach, an approximate solution is first assumed for the unknown variable, usually in the form of phenomenal or a combination of trial functions that satisfies the essential boundary conditions. When the approximate solution is substituted into the governing differential equation, it does not satisfy the solution exactly. The difference between the left hand side and the right hand side of the equation is known as the residual or error. The central idea of the weight residual method is to reduce this error in an average sense over the entire problem domain. That this is achieved by multiplying the residual with set of chosen weighting functions and integrating the solution over the weight. The method enforces the condition that the interval of the weight residual is zero, ensuring the overall error is minimized. Depending on the choice of the weighting function, different formulations such as the Galerkin method, least square method, and collocation methods are obtained. These formulations are widely used in computational techniques, especially in the finite element analysis.
So myself Rajeshwari from third year NMCT. I am going to talk about point collocation method. In this method, we first assume an approximate solution to the governing differential equation. This is assumed solution does not satisfy the equation exactly, so an error called the residual is formed. In the point collocation method, this residual is forced to be zero at selected discrete points known as collocation points within the domain. The main advantage of this method is simplicity. It does not require integration over the domain, which reduces computational effort. However, the accuracy depends on the number and location of the chosen points. The point collocation method is commonly applied in one-dimensional heat conduction problems, beam bending analysis, fluid flow problems, and for obtaining quick approximate solutions to differential equations.
So myself K. Vansha Devi from Mechanical and Electronics Engineering. So my topic is subdomain in finite element analysis. Means a small region of an entire structure where the material properties and physical behavior remain the same. In complex structure, the main domain is divided into multiple subdomains when there are different materials, loads or boundary conditions. Each subdomain is meshed separately and assigned its own material properties, but all subdomains are connected through common boundaries to act as one system. Using subdomains helps to simplify complex problems, improve accuracy, and it's very useful in multi-material and thermostructural analysis.
Myself Tarika from second NCT, least square method. In weight residual method, the least square method is a type of weight residual approximate solution is obtained by minimizing the sum of the square of the residual error over the entire domain. It uses the principle of weighting functions are taken as the derivatives of the residues with respect to the unknown coefficient and the integral of the product of residues. These weighting functions over domain is set to 0. The applications are heat transfer problems and approximate temperature distribution applied in structural analysis for stress and displacement estimation.
So myself T. Srinidhi from third year MMCP. My topic is application of the Galerkin method, which is part of the weighted residual method. This method is used to find approximate solutions when exact solution to a problem are too difficult. We start with an assumed solution which naturally has some error called the residue. In the Galerkin method, we adjust the solution so that the overall error is minimized. It is widely used in engineering. For example, in structural engineering, it helps to predict how beams or bridges bend. In heat transfer, it estimates how it spreads through materials. In fluid flow, it approximates the movement of liquids or gases. It is also the foundation of the finite element method used in designing cars, airplanes, and machinery. In the short, the Galerkin method gives the engineers a practical way to solve complex real-world problems accurately and efficiently.
As you know that all the methods can be only for the approximate solution, okay? But the solution thing is the way of solving the problem is very important. So the point correlation method is very easy to compare to Galerkin, but the way is different for the application oriented. Okay, so that is the outcome of this case study.